Welcome everyone to a quick overview of Lesson 1.3 from Calculus, which is finding limits from a graph. We kind of did that a little bit in the last lessons. The main new thing from this lesson is this idea of one-sided limits. So for a traditional limit to exist, one side and the other, the left and the right, have to meet at the same point. They have to be approaching the same value. That might not exist at that value, but they have to be approaching the same thing. One-sided limits don't have that restriction. We just look at the left or look at the right. So let's look at this f function here. The equation doesn't matter because we're looking at the graph. And if we look at the graph here, the main things that you need to note of is there's a split, and the function exists at 1, but it exists for this piece. So f of 1 is 5. That's an important distinction for us, especially when we get to like the test. F of 1 is equal to 5 here because it physically exists at 5. Now, the limit. Well, the left-hand side is approaching 5, but the right-hand side is approaching 3. And here's how we'll write them. We'll say the limit as x approaches 1 from the left. Since we're coming from the negative side of the graph, we're going to put a little minus there, of f of x is equal to, in this case it was 5, and the right hand side here would be the limit as x approaches 1 from the right of f of x, we put a little plus as the power, is equal to 3. And since these two things are different, the actual limit of f of x as x approaches 1 does not exist. So if the left-hand limit and the right-hand limit are not the same, the limit doesn't exist. It doesn't matter at all if the value exists or not. Let's take a look at another function just so we get it down. So let's erase all of this beautiful work, and let's switch graphs. So here we have an interesting looking graph, and it's in 3 pieces. Here's an important distinction that you could only really get from the equation, so I'm going to add it on there now. We have a little open circle here, a little open circle here, a little open circle here, and a little open circle here. So what do all those open circles mean? F of 0 does not exist, as does f of 4 does not exist, and f of 8 does not exist. So that's all fine and dandy, but limits really don't care about existence. Let's look at some weird spots in the graph. Let's look at this. Right now we only have a value of the graph. The graph is only showing something on the right-hand side. So the left-hand side limit doesn't exist. The limit as x approaches 0 from the left of, in this case, g of x, does not exist. But the right-hand side does. The right-hand side is approaching 2. So that's an important distinction for this one. If you only see one side of it, that side, its limit does exist, but the other side does not. That also means that the limit in its entirety does not exist. So the limit as x approaches 0 from both sides does not exist. Now let's look at some of the other pieces. And I'm not going to use as much notation just because I want this video to really be quick. But at 4, the left-hand limit as x approaches 4 from the left does exist. That would be equal to 2. As x approaches 4 from the right does exist, and that would be 6. But because those two values are the same, are not the same, the whole limit as its entirety doesn't exist. This one, the value doesn't exist, but the limit does, as we talked about in the last lesson. So in this case, as x approaches 8 from both sides, the limit of g of x would equal, in this case, 6. But f of 8 does not exist. I hope this helps, and if you have any questions, be sure to ask me. Example 3 in your workbook is one I would pay really, really close attention to. Other than that, good luck on your practice, and I'll see you in the next video.